Okay, let's have a look at expanding brackets. Now in this case here I'm going to simplify it down to really basic steps, trying not to leave out any steps. So some of you may see shortcuts that you can make, but this is the long way and this is how we explain it to start with. Once you gain familiarity, then you can start taking a few shortcuts. So the first thing we do here is when we see two brackets like this with two terms in each, what we can do is, for instance, we can take the first term here and multiply that by all of that bracket there. Okay, so that would be x cubed times all of that bracket, and then we can also take, and I just note, plus 6y. We must keep the signs with it, and we'll multiply that by all of that bracket there. So what we end up with then is something that looks like this. So we take x cubed and we multiply that by 2x minus 3y. And then we take plus 6y and we multiply that by 2x minus 3y. Okay, and then we expand out those brackets to give us 2. Now we've got x times x cubed, so that's going to be x to the power of 4. 2x to the power of 4 minus 3. Now it's usual to keep them in alphabetical order as well. So 3 times x cubed times y. We don't have to put the times in here. Okay, now it's plus 6y times 2x would be 12xy, and then we would get 6y times negative 3y is negative 3 6s are 18y squared, like so. And then we just collect our terms, all our terms together, simplifying as much as we can. That's the highest power of 4 there. In fact, that's as far as we can go. I'll just undo that little piece there. That's about as far as we can go with that, because there's no like terms. There's no x cubed y terms that we can add things to. There's no x to the power of 4 terms that we can add or subtract. There's an xy term and there's a y squared term. So that's as far as we can go with that. So that is in fact the answer to that one there. I've left the bracket off here. I'll just put that in there. Okay, so let's just apply the same rules here. So it would be a squared times all of that bracket. So we'll try and put it equals here. So here's our a squared, and that would be times a plus 5b. And then it's negative b, note the negative, negative b times a plus 5b. Now if we multiply that out, okay, we get a to the power of 3, a squared times a to the power of 3, plus 5. Now I'm just rearranging the terms in order as I go. 5a squared b minus AB, note that it's minus, and then it'll be minus b times 5b is minus 5b squared. Now we once again go through and see if we've got any like terms that we can deal with, and no, there are no like terms. There's an a cubed, there's a squared b, there's an ab, and there's a b squared, but there's no like terms. There's no other ab's, there's no other a squared b's. So that's as far as we can go with that. We can't take it any further, can't simplify it anymore once we've expanded it. So let's have a look at this one here. Again, this is 3, so we just write down x, and that'll be, this will be the equals over here, that'll be x times 3x minus 1 minus 17 times 3x minus 1. Okay, and then that will equal 3x squared minus x minus 3 sevens are 21, 51 x plus minus times a minus plus 17 times 1, which is 17. Now in this case here we have a couple of like terms. We have a negative x and a negative 51x, so we can simplify those to give us 3x squared minus 52x minus 1x, x minus 51 is minus 52 plus 17. That sorts that out. And now let's just have a look at one more example here. Okay, so again to do this one, it's 3x times 2x minus 4 minus 5 times 2x minus 4. Multiplying that out, we get 3 times 2 is 6x squared (3x times negative 4 is negative 12x minus 5 times 2x minus 10x. Negative 5 times negative 4 plus 20. Again, just using our red pen, we've got some like terms here. Those ones are like, just as we did up in here, we had the x's were alike, so we can collect our like terms together. And so, just to conclude that one, we can go 6x squared minus 22x minus 12x minus 10x minus 20 plus 20. Okay, we could actually simplify that a little bit because everything here is divisible by 2 in this case here, so we could it wouldn't actually change the fraction at all, or the equation, so we could divide by 2. I'll just put that over just in red over here. Divide by 2. That's just a bit of a technical maths issue there that we could do if we wanted it. So it could be equal to 3x squared minus 11x plus 10. And there we have it, expanding brackets for examples.